Today I want to try something different, very different for me, that is recording myself writing code. And to do that, it's gonna be this game engine that I have been working for like a long time and multiple pieces. It's all over the place. And I want to try to put it all together. And as I do, I want to share it with you. It's an open source project. It's gonna be linked in the description, and you can follow along, download, try, and criticize me for as you see that I'm doing stupid things here. I know I've been learning a lot in the process of doing this, especially like recording stuff, but mostly about coding. So I really enjoy working with C++, and I'm gonna be working also with Zig on this one, which is a language that I'm I'm following for some time now, and I think it's very interesting. So if you're interested in that, welcome to join me. And so the core thing of this game engine is the hot reload. The reason I'm doing this is that as a developer, I want to write the code and see changes immediately, and I don't want to move a pixel and restart the program and see if it actually is there, right? I guess this is something that I just always like to do, and also because it's just gonna be real fun doing this. I really like working with like lower level stuff, shaders and GPUs and all this. So join me on this. Well, I'm gonna start by demoing the code, showing some of the code base, and then if you're curious about it, you can look at the project and just explore the code base. I hope this works out, and I hope this is gonna be fun for everyone. So let's start by showing what how it's looking now. So I can run this. It's just a basic metal triangle, this famous one. And but what is interesting about this? Let's put it on the side here. Let me get this guy. So what is cool about this? I have the metal file that is the shader, and I can actually change just this. Let's see. I'm gonna just make it everything darker here by multiplying the color. And then when I build again, hopefully it will change. Yeah. So you can see that as the library was built again, including the metal library, the host application is just loading automatically. But it also works. Let's do this. Go back to 1 here. So actually get rid of this. And let's change the color a little bit. Let's use some like so a white one of the corners instead of the red. Let's make it white. So let's see how it looks. Yeah, there you go. You can see the white one here. So these are like the 3 vertices and the colors for each one. I can actually I can actually change stuff, like let's go back to red and just anyway, it's obviously hopefully anything that I do here will reflect there. I don't know about errors, if it causes an error. Um, it should be caught in the build, but it didn't work on this. I'm not worried about this yet. I'll wait until it happens, and then I'm gonna figure it out. Cool. So this is the idea. I want to build this project and have and see it's like automatically refreshed here. And this is gonna be the base of the entire thing that I'm doing. This the whole thing is so I can write code and see it immediately, kind of like what React Native is doing these days, and have this sort of developer experience, you know, where you can do that. Um, so one of the things that I learned about this is that in the macOS, the app is sandboxed. And I was trying to remember how I turned it off, and it's actually just simple. It's an entitlement. In this case, for the macOS one, it just turned it off. This allows us first to use the file manager and actually scan the directory that I want for the latest file, so the youngest file here. And I have to do this. The interesting thing is that those files are cached, so there's no way. I mean, there's probably a much elegant way of doing this. So my solution, because I just want to make it work, is to generate files with the timestamp. So you can see here we have the timestamp. You can see here in the build Zinc file. I'm adding the timestamp in seconds to the file name every time. I also had to add a little bit of a cleanup function here, so I clean the directory. There's probably a more elegant way of doing this as well, but that's good enough for now. So I'm deleting this output file, directory file, and I'm generating a new one. Here in my host application, I'm just looking for this new file. So it's like this. I am updating the file name. It looks for the new one, compares to see if it's the same. If it's not the same, it changed, and it returns true. So whenever I update this, I will also update this and also recreate my metal device. And just this one, I'm not even sure if I need to do, but I think it might be interesting to use this. So restart the device basically. So it's not starting anything. I should learn more about this if I need to, but for now it's fine. And I can call all the functions like resize, draw, start, and including the on hot reload and everything. It's been called from the new library that's been loaded. So that's how it works. Let me think about if there's anything else special about this. What I found interesting is that even the metal library file gets cached somehow, and I need to change the file name. So I'm guessing there's something either the OS does or how the library loading works, and then if you already have it, it's cached. I don't know. It just don't reload if I do that. I'm just happy that this works. You know, so so the way this works, let me show you how I'm calling the library functions here. I'm getting the symbols right from this dynamic library, and I made it look this for. Probably gonna need more. For now, this for is working all right. And here's how the header looks like. Here are all the stuff that's coming from the hosts app, right? So I need all this metal stuff that's coming from there. The device, the shader library, that's stuff that I'm gonna use in the C++ part of the code to actually render stuff. And these are external functions. So the external functions that are being called from the other app, yeah, like this one. So these are just the type definitions. I define the type here because it's easier to use here. I don't want to retype it here. So I'm declaring them, and I store all these pointers to those functions. And then after, when the view starts, I will try to reload everything. So the same function. So we'll be reloading here the dynamic library, also the shader library, and call it onStart. So this is gonna happen only once in the final application, right? In the game at the end of it. So not in development mode. In development mode, you would see the onHot reload being called. So it's only when the file changes, this is called, and then onDraw is called in every frame. I have to pass this every time, so make sure that the library, the device, and everything is up to date on the DLL side of it. And this is just the on resize that it's gonna be needed later to adjust all the viewports and everything. On the C++ side here, the implementation is very simple. Every time you call, just call the engine, and it's simple for now. It's gonna be very complicated later, I suppose. Hot reload. I'm also calling the init because it initialized some scenes and stuff for now. Maybe later just gonna store this and they'll have to call it again. On draw, it will. So every time the DLL is loaded, the view is gonna be empty, and then because all the memory has shifted and the new DLL is working with the new memory addresses, so all variables are restarted. When it's null, it means that I'm receiving the first frame, so I have all the information I need. That's when I initialize the render. And for every frame, and just update the engine and then render this. So this all the logic for the scene and everything is going to be probably here. Now the Apple renders, I'm going to split in multiple types of render. The Apple render, I'm calling it Apple because it's supposed to work for iOS and macOS. If it's not the case, it'll change later, but I'm pretty sure that it's going to work out like this. And now we're starting to work with the actual like fun stuff. So all the command queues, rendering encoder, the pipeline. For now, I created this method called clear. Doesn't make any sense, but I'll show you in a bit. So here's just when initializing the renderer. You create a command queue. This is gonna change a lot, but it's already getting the library that loaded on the host app and getting all the functions from the metal shader. Here's just setting up the pipelines. Okay, and in here I'm just creating a little bit of a buffer to create a triangle. So have positions for all the vertices. So there's like XYZ for every vertex and the color for every vertex. So you're gonna see red here. No, this is not red. This is gonna be red, and then green and blue. So 100% blue, 100% green, 100% red. Creates the buffer, and then just copying the memory into the buffer. So now the GPU can use this data to render. The actual draw calls are called here. This is I'm just copying from the C++ example that I found using metal, and I need to be sure if I actually need to handle allocations. I'm supposing I should use it because I don't know what's going to happen inside of all these commands here. Maybe it's allocating stuff and expecting the auto release pull to deallocate. I might be wrong. Please correct me if I'm wrong. And it's actually just drawn. So setting the buffers for color, position, calling the primitive triangle, encoding everything, and setting it to the drawable. And part of the engine here, let me show this part. This is, I'm just calculating the time in milliseconds, so you get the delta for every frame, so you can update the scene based on this delta time. This is going to be used everywhere, basically. I also create this scene object in class that I'm not sure I'm going to use it, but I wanted to experiment with something like that. So the scene is supposed to handle all the entities and put everything in place and draw everything. Right now it's really just calling the renderer. The renderer clear is this is the part that is a little bit complicated because I'll have to abstract a lot of the rendering parts. I don't want to abstract too much. Um, I'm trying to, I'll try to do the least amount of abstractions here. Otherwise, you end up building like a version of Metal or OpenGL or Vulkan or DirectX just to render everything. Hopefully, I'm gonna be able to make a more specific type of rendering in an engine, so there's no need to abstract too much. And but it will have to. It's gonna limit a little bit the capabilities, but I'm fine with it. So this, in the end, everything is like just these are the main things that's related to the hot reloading. So this part of the code, it's actually being called from the host app, and it's updating and everything. It's working fine. It's actually really pleasant to see everything changing in real time. I hope this, as this is the core of this whole thing, I hope this actually makes sense, and it's gonna be fun to use this thing. Okay, I think this is it for today. Please let me know if it makes sense to you, if it's something you would like to use, or if you're just curious about how this is gonna play out. Uh, I'll be I'll be sharing more like hands-on coding later. It's not easy for me to write, speak in English, and do everything and type and code and everything. So my brain is just like 100% here capacities. But yeah, just let me know if you have any suggestions, anything. It would be fun to know what you guys think about it. Thank you.